Question 1a, part 1. What is the colour of the flame observed when magnesium burns? Well, this is one of the most common and most memorable chemical reactions in a chemistry lab. The magnesium burns with a white flame. And on to part 2 then is write a balanced symbol equation for this reaction. Well, magnesium is Mg. We don't put in a 2 here because it's not reacting with anything. So we'll just leave it as Mg. It's burning in air. That means it's reacting with the oxygen in the air. And it's diatomic, so we write O2. Remember, oxygen has to exist as two atoms that are covalently bonded together. So it's like that. And then that goes to give magnesium oxide. So both of these elements, the magnesium and the oxygen, have a valency of 2. So it's just MgO. And then we need to put a 2 in front of the MgO and a 2 in front of the Mg. The next question then has to do with the reaction of metals with steam. So if a metal reacts slowly with cold water, it can be speeded up by reacting with steam. So I have to label then A and B. Well, A is a delivery tube and B is a gas jar. Now be careful here that you don't say glass jar, if that's wrong. Part 2, explain why the damp mineral wool is heated. As you can see here, we've got damp mineral wool. That's soaked in water, and when it's heated, the water evaporates, turns to gas, which is the steam, and then the steam passes over the hot metal. So the damp mineral wool is heated to generate steam. And part 3, the gas produced. Well, when a metal reacts with water or with acid, the gas produced is hydrogen. And then finally part 4, name a metal which does not react when heated with steam. So you're thinking here of a metal that's down at the bottom of the reactivity series. Well, copper is at the bottom, so it's a good one to put down. You could also give even more unreactive elements like silver or gold, and there are others, but those are probably the most common ones. Part B, suggest the name of metal X. Well, I can see that there's no reaction with cold water or with acids. This is a fairly unreactive metal. Now it does react with oxygen and forms a black coating. So you need to remember that the metal that does that is copper. So X is probably copper. And part 2, describe what you'd observe when sodium reacts with cold water. There are 3 marks for this. So I'm going to think of 3 different things. Heat given out or heat released is a fairly common observation in any chemical reaction. So if you're stuck for something to say, just put down heat released. The sodium with water also produce bubbles, or there's fizzing. You can say gas given off or gas evolved, not just hydrogen on its own. Okay, so the word gas must be there. But the fizzing, bubbles and gas all mean the same thing. They're not 3 separate marks. The sodium metal would disappear. And we've got our 3 things. There are others you could write, and I'll just put down some of them here. Part 3, write a balanced symbol equation for the reaction of sodium with water. So sodium is Na, H2O is obviously water, and a metal plus a water gives a metal hydroxide. So it's NaOH. The sodium and the hydroxide ions both have a valency of 1, and then hydrogen is formed. Hydrogen is a diatomic gas. It's like oxygen, nitrogen, chlorine, fluorine. Has to be balanced. And we can do that by putting a 2 in front of those 3 substances. On to the next question. You can see here we've got a partial reactivity series, and then question A, silver does not appear on the above series. Copper metal will react with silver nitrate solution to form silver as shown below. So part 1, Write a balanced symbol equation for the reaction of copper with silver nitrate, and then that forms silver and copper 2 nitrate. Well, copper is Cu, silver nitrate is AgNO3, and you'll find the valency of silver on the back of the data leaflet. You'll see that it's Ag+, so it has a valency of 1, and the nitrate has a valency of 1 because it says NO3 minus. And this minus indicates the valency. Okay, so just get rid of that. And then that goes to give silver plus copper 2 nitrate. Now the copper has a valency of 2, which is what that says, so we're going to swap it over and put it after nitrate. And because this is a molecular ion, it is made up of different elements and it has to go inside brackets. The nitrate has a valency of 1, so we don't need to put it after the copper. That's the formula written for each individual substance. It now has to be balanced. Well, you could hopefully see that there are 2 nitrates on the right, only 1 on the left. Put a 2 there. That now produces 2 Ags, so then I have to put 2 Ags there. And part 2, indicate the position of silver on the reactivity series. Well, silver must be less reactive than copper because copper is able to displace the silver from silver nitrate solution. So silver would go there. Part 3, silver nitrate solution is colourless. What is the colour of the solution at the end of the reaction? Well, if you remember, copper 2 nitrate solution was formed, and copper solutions are usually blue. That's something you just learn. Okay, so copper solutions are usually blue. Explain why the copper displaces silver. Well, that happens because copper is more reactive than silver. C, part 1, explain why aluminium shows a lack of reactivity, even though the reactivity series would suggest it is a moderately reactive metal. Yeah, this is an unusual one. So you've got magnesium, aluminium, zinc, and then you've got other metals, obviously. The aluminium is above zinc in the reactivity series. But when aluminium is reacted with water or steam or acid, it appears not to react. So it looks as though it's less reactive than the zinc, even though it's placed above zinc in the reactivity series. And that's because the aluminium, when exposed to the air, and this is fresh aluminium, it forms a protective layer of aluminium oxide. And this protective layer then stops the aluminium from reacting. On to part 2. Write a word equation for this. Well, you're just writing aluminium plus copper 2 oxide, and you can see it goes to give aluminium oxide plus copper. You may get away with saying just copper oxide here and leaving out the 2, but as copper is from the middle part of the periodic table, it can have a couple of different valencies. You can have copper 1 oxide, but in this case it's copper 2. So I'm including it just to make sure, and also to be careful, you don't put in the 2 over here. So let's see, if you do that, that means copper 2 ions, and that's not the same as Cu, which is what this copper is, okay? So when you put the Roman numerals after the metal like this, that means the metal ion. Question 5 is obviously a question about adding different metals to copper 2 sulfate solution and recording the temperature rise if it happens. So part 1 then, state 2 factors which should be kept the same in the experiment to make it a fair test. Now there are a number of answers you can give. One of them would be to use the same volume of copper 2 sulfate solution. And following on from that, then the concentration of the sulfate solution would have to be the same. And the word solutions here probably is not needed because you're told up in the question that the copper 2 sulfate is a solution. So I'll just put that inside brackets. You could also say that you use the same surface area of the metal and then the same amount or the same number of moles of metal, and that's better than saying the same mass. Part 2, state and explain which of the metals gave the least reliable temperature rise. If you look at the results over on the right, you can see that for the magnesium results, experiment 1 produced 11.5 degrees Celsius increase, experiment 2 16.5. But when you look at the others, you'll see they're actually quite close, or they're the same. These two values should be very similar, or they should be the same. The fact that there's quite a difference between them would indicate that they're not reliable. And you wouldn't just say here that there's a 5 degrees Celsius difference between it, because that's not a comparison. So you've got to say that they're too far apart, and that indicates obviously that that's compared to all of the other ones. So state and explain which of the metals is the most reactive. Well, that's obviously magnesium because it produced the highest temperature rise. Part 4, explain why there's no temperature rise when silver is added to copper 2 sulfate. Well, silver is below copper in the reactivity series, so it's less reactive than copper, and that's why it just wouldn't react. So there are just 3 different ways of answering that. Next question, why do the results make it impossible to decide which of the metals is least reactive? Again, looking at the results, you can see that silver and gold produce the same results. So it can't tell from this experiment which one of those metals is least reactive. And part 6, a balanced assembly equation for the reaction of zinc, which is Zn, with copper 2 sulfate. It is CuSO4. The zinc is more reactive than copper, so displaces it, and it forms zinc sulfate, and copper is formed. Now, if you're asked for colour changes here, the copper 2 sulfate solution is blue, zinc sulfate solution is colourless, so it goes from blue to colourless. Heat would be released, copper is formed, and so you'd also notice a brown solid forming. Part A of the next question, write a balanced assembly equation for the reaction of copper with air. Well, copper plus oxygen, which is again what it reacts with in the air, to form copper 2 oxide, needs to be balanced like so. Next part, write a balanced assembly equation for the reaction of strontium with water. So metal plus water gives the metal hydroxide plus hydrogen. Strontium is Sr plus the water, and that will get you 1 mark. So even if you don't know what else to do, you at least attempted to try and get one of the marks. So I'm just writing down what the question is telling me, the reaction of strontium with water, and then include an arrow. That will get you 1 mark. This goes to form strontium hydroxide. The strontium has a valency of 2. It's in group 2. So I swap it and put it after the OH. And then I need to put brackets around that because those are different elements. Hydroxide has a valency of 1. So it just stays like that. And then hydrogen is formed. And then to balance it, we've got 2 hydrogens there plus 2 is 4. A 2 is required there. And part 2, compare the observations made when strontium reacts with water and when potassium reacts with water. Okay, well, you can see from the image that the strontium is at the bottom. It sinks. It's like calcium, which sinks, whereas the group 1 metals, sodium and potassium, float. So that's the difference. You can see as well from the image there are bubbles formed, there's fizzing, and that's the same as in the potassium with water reaction. The potassium would burn with a lilac flame, whereas strontium doesn't produce a flame. So that's 3 marks already. You could say that both disappear. B part 1. A balancing equation for the reaction between strontium and silver nitrate. So the strontium replaces it. It's in group 2. So the 2 needs to be swapped. The valency needs to be swapped. And then that will form silver. You can see there are 2 nitrates on the right, only 1 on the left. So by putting the 2 there, it balances the nitrates, but it has now formed 2 Ag on the left, so we need to put a 2 on the right. Name the products when calcium reacts with cadmium 2 nitrate. Well, the calcium displaces the cadmium because it's more reactive than cadmium, and so calcium nitrate forms and cadmium. Now do not say cadmium 2, because this 2 indicates that those are cadmium ions. So again, this was in an earlier question, or one that was similar to this. If you write that, it's wrong. As I said, that would indicate that it's CD2+, but it's not. When the displacement reaction takes place, it's cadmium or cadmium atoms that are formed. And then part 3, we have to indicate the position of strontium and cadmium. So if we go back up to the table, strontium reacts with all of the solutions. So it's more reactive than all the other metals. It's going to be more reactive than the calcium, cadmium, copper, etc. But it's not more reactive than potassium. Strontium is in group 2, and group 2 metals are less reactive than group 1 metals. So I'm going to place strontium below potassium, but above calcium. And then the other one that we have to do is show where cadmium goes. By looking at the table, we can see that it's more reactive than copper and silver, but not as reactive as the iron. So it's going to go in here. Next question. This is about phytomining. So part 1, explain how a solution of copper 2 ions is produced from the plants. Now you're told in the introduction that the first stage involves plants absorbing copper 2 ions from the soil, so we don't need to talk about that. So what happens after that process? Well, the plants are burnt to an ash, and then we have to say how a solution of copper 2 ions is produced. So after the plants have been burnt to this ash, acid is added, often sulfuric acid, but it can be any acid. Part 2, so scrap iron is added. Explain why the iron can displace the copper. That's because iron is more reactive than copper. Or you could say iron is higher in the reactivity series than copper. Now don't just say that iron is more reactive. You must say than copper, so you must compare the two. Part 3, write a half equation for the formation of copper from copper 2 ions. Well, it's from copper 2 ions. And copper 2 ions are that Cu2+. So there's a mark. Now this on the left is positively charged, obviously. This is neutral. These copper ions must be gaining electrons. And this here tells you how many. There's going to be +2 electrons. And part 4, one advantage of phytomining over traditional methods. Again, it's things like less noise pollution, less dust pollution. Don't be saying less pollution, it's too vague. So there are some other suggestions. They're not the only ones. But don't say things like it's cheaper. Again, that's not allowed. On to this question. The image below shows 3 metals reacting with hydrochloric acid, and you can see the bubbles of gas in all 3. You're told that there are bubbles in all reactions. So suggest why the reaction between tin and hydrochloric acid would not be used to prepare a gas jar of hydrogen in the lab. Well, even though all 3 produce hydrogen gas, you can see the one with tin has very few bubbles. So even though it is producing hydrogen, it's not producing much, and it would take a long time for the gas jar to be filled with hydrogen. Next, we have to write a Balance-Summed equation for the reaction between zinc, which is Zn, with hydrochloric acid, HCl, goes to give zinc chloride and hydrogen. Need to balance that by putting a 2 in front of the HCl. Remember, this is metal plus acid, gives us salt plus hydrogen. Explain which metal is most reactive. It's going to be magnesium. It had the most bubbles. And that's needed because it does ask you to explain it. And then one physical property of hydrogen gas, again, this could be a number of things. It's less dense than air. It's colourless, odourless, insoluble in water. Again, that about covers it, I think. Don't say it's flammable. That's a chemical reaction. Okay, A, part 1. Write a Balance-Summed equation for the reaction of potassium with water. Okay, plus H2O. Metal plus water gives the metal hydroxide and hydrogen. And then 2's go in front of those. A few drops of phenolphthalein were added to the solution. Well, the solution is potassium hydroxide. Hydroxide ions are alkaline, and phenolphthalein turns pink in an alkaline solution. Part 3. Describe in terms of electrons what happens to the potassium atoms when they react with water. Well, the potassium atoms turn into potassium ions. So if you think of the electronic configuration of a potassium atom, it's 2, 8, 8, 1. So it's going to lose this outer electron to become 2, 8, 8. And now it has a full outer shell of electrons, which makes it stable. So basically all you need to write here is that they lose 1 electron to form K plus ions. Part 4, we have to compare the reactivity of group 1 with group 2 metals. Well, you can see from the information here that group 1 is more reactive than group 2. And the question does state that evidence has to be given from the table to support the answer. So if we look then at the table, calcium is in group 2, and the element that's in group 1 beside it is potassium. So you can see here that potassium takes 5 seconds to finish and calcium takes 42. So group 1 is obviously a lot faster. You could also look at sodium. It's group 1, and the element beside it is magnesium, and it's not finished until after 300 seconds. So that's group 1 and group 2. Again, you can see that group 2 takes a longer period of time. For B, part 1, after I write a Balance-Summed equation for the reaction of iron 3 oxide with aluminium. Well, iron 3 oxide is Fe2O3 plus aluminium. Aluminium is more reactive than the iron, so it displaces it to form aluminium oxide and iron. This then has to be balanced. So we've got to put a 2 in front of the Fe, and then we put a 2 in front of the Al. For this question, I've already answered it actually. a few moments ago. This reaction occurs is because aluminium is more reactive than iron. Part A of this question is a nice question. It's to test your knowledge on how some metals react with oxygen and with cold water. So with the first part here, then we're going to look at how copper reacts, or the observations that occur when copper is heated in air. So we've already got information about potassium, so you'd use this as a guideline. So you're told here that potassium is a grey solid metal. So you could do then the same thing for the copper, in that it is a brown solid or a red-brown solid. There are different ways of describing the colour of copper. As I said, brown is fine. Red, brown, you could have orange as well, red, orange, but not red on its own. Okay, you can't say red. Okay, the next one then, we see that potassium burns with a lilac flame. Now, copper doesn't actually burn, but it glows red or glows orange. And when it's in the flame itself turns a blue-green colour. And when you're describing that, you have to have both words. You can't have blue or green on their own. And then the final part here is potassium forms a white solid. So then you just write in here, oh, what does the product look like when copper reacts? Which is obviously going to be copper dioxide, and it's a black solid. Now there may be one or two more acceptable answers, but the ones written down will be the most common ones. On to the next part of it then. We have to write the balance symbol equation for the reaction of potassium with oxygen. So it's going to be K plus O2 goes to give K2O. Potassium is a valency of 1, don't need to put that in. Oxygen is a valency of 2, you swap it. Now it needs to be balanced. We need to put a 2 there to balance the oxygens, but now the potassiums, 4, so a 4 has to go there. Next one, 3 observations during the reaction of potassium with water. Copper obviously doesn't react. It's at the bottom of the reactivity series. When potassium reacts, again, there are a number of things here. So, for example, so you can see in the most common ones, you could also say a colourless solution formed. That would also be acceptable. So you need to have 3 things here. So up here, you need a maximum of 3. This one's worth 3. This one's worth 3. And then the final one is worth 3. Well, potassium is obviously K plus water gives potassium hydroxide plus hydrogen. And then to balance it up, you need 2's in front of those 3 substances. Now I have a question on phytomining. So 4 key steps, and it's important that you just use the correct words for this. So step 1 is that plants absorb copper compounds, and that's all that's needed here. You can also say copper ions, copper ores, metal compounds, but you cannot say it absorbs copper. The next step is that the plants are burnt to an ash. Now I've already mentioned plants up here, so I could just say they're burnt to an ash, but I'm just going to write in here plants are burnt to an ash. Third step is that acid is added, and this can be a named acid. So it's usually sulfuric acid, but you could have another acid such as hydrochloric. But acid is the key thing. And then finally, that'll form a copper solution. We want the copper out of solution. That's why scrap iron is added, and that causes a displacement reaction to occur. Looking at this table, I can see here that magnesium reacts with all 3 solutions. That's the most reactive. Zinc reacts with 2 of them. Lead reacts with 1. Silver doesn't react at all. So it's going to be magnesium is most reactive, followed by zinc, lead, and finally silver. Write a balanced simple equation for the reaction between magnesium and silver nitrate solution. Okay, so magnesium plus silver nitrate, and the metals just switch places. So it's magnesium nitrate. Need to be careful here because magnesium and the nitrate do not have the same valency. Magnesium has a valency of 2, so we've got to swap it. And put brackets around the nitrate because the nitrate is made up of nitrogen and oxygen. The nitrate has a valency of 1. Oh, we don't need to put that in. And then we get silver. That obviously needs to be balanced. You can see that there are 2 nitrates here and only 1 here. Got to put a 2 there. And then to balance, put a 2 in front of the AG on the right. Part 3. The reaction between magnesium and zinc nitrate solution may be described as redox. Explain in terms of electrons why it's a redox reaction. Now, I need to be careful here because this question is talking about magnesium and silver nitrate solution, whereas this question is magnesium and zinc nitrate. It's almost a trick question. So just be careful there. So it's good when these types of questions just to underline or highlight the key terms. So what I'm going to do is write the full balanced simple equation first, and then we'll look at what's happening. So here is the full balanced simple equation. Now you can see that the magnesium, Mg, goes to magnesium ions. So these are the atoms, these are the ions, and we know these are ions because it has joined up with the nitrate. So whatever it's joined up with, then this is the ion. Likewise here, these are zinc ions because it's joined up with something else. These are zinc atoms. So this and this will be neutral, and then the zinc ions and the magnesium ions will be charged. So I'm going to start off with the metal. That's how I always do this. I talk about the metal atoms first, and then I talk about the metal ions. So what happens to the magnesium? Well, going from Mg to these ions, and the magnesium ion is Mg2+, that happens when magnesium loses electrons. And I'm just going to write in the half equation. Now, you don't have to put it in, it doesn't say to do it, but I'm going to do it just to make sure that you understand what's actually happening. So there's the half equation. Half equations always contain E or E minus somewhere in the equation. Now, we're not finished with this part just yet. We'll have to give a definition of oxidation. Oxidation is loss of electrons. Remember our acronym OIL RIG. So oxidation is loss of electrons, reduction is gain of electrons. So I'm going to put in then this definition. Be careful how you write this. For example, if you've written magnesium loses electrons and this is oxidation, you will not get that second mark. You must give a clear definition of what oxidation is. So say it one more time. So this is what you have to write, or loss of electrons is oxidation. That's just the same thing the other way around. But do not write something like magnesium loses electrons and this is oxidation, because you haven't stated that oxidation is the loss of electrons. So I hope that's clear. Okay, now I'm going to move on to the zinc ions, or I could just write the formula for zinc ions, Zn2+. But be careful here. It is not Zn or zinc. If you write Zn or zinc, gaining electrons, that will be wrong. It's the ions which gain electrons. Again, I'm going to just write in the half equation to show what happens. That's it. Now I'm going to give the definition of reduction. So the magnesium undergoes oxidation, and then the zinc ions will do the opposite. So it's reduction. And if we look here, reduction is gain of electrons. Again, be careful that you don't lose a mark by saying zinc ions gain electrons and this is reduction. You must give a clear statement that reduction is the gain of electrons. The next or final thing we'll have to do then is explain why it's redox. Well, that's when you've got a reduction and oxidation occurring in the same reaction. For this here, you could say oxidation and reduction occur at the same time, but you often need to mention the word reaction somewhere in the answer. So for example, you could say here, it's a redox reaction because oxidation and reduction both occur, and that would be fine. Next question. You have to identify metals 1, 2 and 3. Well, metal 1 is a grey solid and burns with orange sparks, forms a black solid. Okay, the orange sparks is a big clue there. That must be iron. And that ties in with the appearance of iron, which is a grey solid, and it forms an oxide of iron, which is black. Metal 2, it's a red-brown solid. It glows red, so it doesn't actually burn, and it changes to a black solid. Well, all of those things relate to copper. Final one, grey solid burns with a brick red flame. Okay, well, the brick red flame is the big clue there. That must be calcium, and calcium oxide is a white solid because calcium is in group 2, and group 2 solid compounds are always white. Part 2. So based on answer to A1, write a balanced symbol equation for the reaction of metal 3 when it's heated in air. Well, metal 3 is calcium, so that is going to be calcium plus oxygen, which is what it reacts with when heated in air, forms calcium oxide. Both the calcium and oxygen have a valency of 2, and then to balance it, we've got to put a 2 there and a 2 there. B part 1, write a balanced symbol equation for this reaction and include state symbols. Well, aluminium is Al. Steam has a chemical formula H2O. State symbols, so that means that this is going to be a gas, not L, which would be obviously liquid water. Aluminium is a solid, and then that goes to give aluminium oxide. The aluminium has a valency of 3, so we swap it. The oxygen has a valency of 2, so we swap it. So that's why it's Al2O3. Now this is an ionic solid. This is a metal, non-metal. It's an ionic compound. It's going to have a high melting point. So I know this is going to be S for solid, and then hydrogen gas, which is H2, and then it's a G. Now it has to be balanced, so that's it done. Next part shows the reaction of a metal, this time aluminium, with steam. And we'll have to put on the labels A, B and C. So A is damp mineral wool, which you can see here. Well, the damp mineral wool goes at the very end of this boiling tube. The aluminium then goes somewhere around the middle, so it would be there. And then the hydrogen, well, it gets produced and collected in the gas jar, so it's going to be there. Explain in terms of oxygen why the reaction of aluminium with steam is described as a redox reaction. So I've written the balanced symbol equation here just so we can have a look at what's happening. Now you can see that the aluminium goes to aluminium oxide, so the aluminium clearly gains oxygen. And we know that the gaining of oxygen is oxidation. And then the hydrogen, or you could say the water, is losing oxygen. So you can see here it goes from H2O now just to H2. So oxygen is lost, and reduction is the loss of oxygen. So that explains why it's redox. So again, I'm just going to point out here You need to be careful and not lose an easy mark. So aluminium gains oxygen, and then if you just say, and this is oxidation, you will not get that second mark. It must be a clear definition of oxidation. And you do not give the answer in terms of electrons because you're clearly told it has to be in terms of oxygen. So now I'll move on to the reduction process. So the steam or the water, you could write H2O. You can even write hydrogen for this one because obviously the oxygen is bonded to the hydrogen, and so in a sense the hydrogen is losing the oxygen. Now we give a definition of reduction. Now remember, do not say that the steam loses oxygen and this is reduction. I'm going to give a clear definition of reduction. And finally, definition of redox. Now I haven't mentioned the word reaction anywhere here, so I'm going to include reaction in the definition. On to the final few questions. So based on your knowledge of the reactivity series, predict which of the following would occur. So if we do, let's see, magnesium, aluminium, zinc, copper, that should cover all of the metals. So we've got sodium in there. Now, sodium's a group 1 metal, and group 1 metals are the most reactive metals in the periodic table. So it'll go at the top. So let's see, the first one then, aluminium and zinc sulfate. Well, aluminium is above zinc in the reactivity series, so it will displace the zinc. So a reaction is going to occur there. Now remember, aluminium appears not to react, but the reason it's placed above zinc is because of that protective oxide layer. And if that oxide layer is removed, then aluminium is more reactive than zinc. On to the second one, copper and steam. Well, copper's way down at the bottom of the reactivity series, so nothing's going to happen. Zinc and sodium chloride. Well, zinc is below sodium, so it's not able to displace the sodium. So no reaction here. Magnesium and steam. Yes, magnesium does react with steam. It forms magnesium oxide and hydrogen, so that's going to react. D1. Which half equation represents oxidation? So this is we got to remember, oil rig. Oxidation is loss of electrons. Well, hopefully you can see that it goes from Mg to Mg2+. The magnesium is losing electrons, so this is going to be oxidation. And final question, state the colour change during the reaction. So this here is going to be magnesium is added to a copper 2 solution. So for example, it could be copper 2 sulfate, it could be copper 2 nitrate, copper 2 chloride, etc. Well, copper solutions are usually blue. So we can say that the colour starts off as blue, and then the magnesium is going to displace the copper and form a magnesium solution. So, for example, magnesium nitrate or magnesium chloride, whatever it happens to be. Magnesium is in group 2, and solutions of group 2 compounds, same as group 1 compounds, are always colourless.